Welcome back to the CompTIA SecurityX CS005 series. In this session, we'll cover topic 3.6.3, SCAP Workflow Automation, which is all about automating vulnerability management, configuration checks, and compliance using standardized formats. What is SCAP? SCAP stands for Security Content Automation Protocol. It is a framework of standards developed by NIST to help organizations automate the process of assessing, monitoring, and improving their security posture. Instead of manually checking for vulnerabilities and compliance, SCAP allows security tools to read and process machine-readable security data for faster and more accurate assessments. SCAP is widely used in vulnerability scanners like Nessus, OpenVS, and Qualys, and is essential for organizations working under regulatory requirements like FISMA or DISA-STIGs. 1. OVAL, Open Vulnerability and Assessment Language. Let's begin with OVAL. Full form, Open Vulnerability and Assessment Language. OVAL standardizes how we describe vulnerabilities and system configurations. Think of it as a recipe that tells a security tool exactly how to check for a specific vulnerability or misconfiguration. Example, an OVAL definition might say, check if Windows Server 2019 has Security Update KB5025.221 installed. This ensures all security tools use the same method when identifying vulnerabilities, which improves accuracy and consistency. 2. XCCDF, Extensible Configuration Checklist Description Format. Next is XCCDF. Full form, Extensible Configuration Checklist Description Format. XCCDF is used to define security benchmarks and checklists in a machine-readable way. Instead of manually comparing your systems to compliance checklists, XCCDF lets tools automatically assess configuration settings. Example, an XCCDF file may list all the required configurations for a system to meet CIS benchmarks or DISA-STIGs. This makes compliance reporting much faster and helps organizations stay aligned with industry and government standards. 3. CPE, Common Platform Enumeration. Now CPE. Full form, Common Platform Enumeration. CPE provides a standard naming system for software, operating systems, and hardware. Example, instead of writing Windows Server 2019 Data Center Edition, a CPE string might say, CPE/O, Microsoft, Windows_Server, 2019 Data Center. This unique identifier makes it easy for vulnerability databases and scanners to match the correct platform to known vulnerabilities. 4. CVE, Common Vulnerabilities and Exposures. Next, CVE. Full form, Common Vulnerabilities and Exposures. CVE gives each publicly known vulnerability a unique ID, making it easy to track and share information. Example, CV20-33397 refers to a specific Microsoft Outlook privilege escalation bug. Using CVEs ensures everyone is talking about the same vulnerability, whether they're using Nessus, Qualys, or a government database. 5. CVSS, Common Vulnerability Scoring System. Lastly, CVSS. Full form, Common Vulnerability Scoring System. CVSS provides a numerical score from 0 to 10 that represents the severity of a vulnerability. Example, a CVSS 9.8 score means the vulnerability is critical and needs urgent attention, while CVSS 4.0 might be considered medium risk. This scoring system helps security teams prioritize their remediation efforts effectively. How SCAP works in practice. Here's how the pieces fit together in a workflow. CPE identifies the software and system. CVE lists known vulnerabilities for that platform. OVAL tells the tool how to check for those vulnerabilities. XCCDF provides compliance checklists for the system. CVSS scores each vulnerability so teams can prioritize fixes. Example, a scanner detects you're running Windows Server 2019 via CPE. It finds a missing security update, CV20-3233397. OVAL tells it exactly how to check if the patch is missing. XCCDF verifies other security configurations meet CIS benchmarks. Finally, CVSS gives a vulnerability a critical 9.8 score, so you know it must be patched immediately. Why SCAP matters. SCAP saves time, reduces errors, and improves visibility by automating vulnerability scanning and compliance assessments, standardizing data across different tools and platforms, helping teams prioritize remediation based on real-world risk. This makes SCAP a powerful tool for enterprise-level vulnerability and compliance management. In summary, SCAP and its components, OVAL, XCCDF, CPE, CVE, and CVSS, help organizations streamline security processes, automate assessments, and prioritize responses. In our next session, we'll continue exploring automation techniques for enterprise security in the CompTIA SecurityX series.